This is Mr. Ashton going through the Mathematics Unit 1 Non-Calculator intermediate paper from the November or autumn of 2016. Okay then, so first page is the formula list. We may need to use that, may not. We'll skip on to question 1 for now. Okay, the first question says, what is 0.4 times 0.7? Now, the most common wrong answer here will be 2.8. It's not. It will be based on that. If I say what is 4 times 7, we know that's 28. But what have I done to 4 to get to 0.4? I've divided it by 10. And what have I done to 7 to get it to 0.7? Also divided by 10. So that means I need to divide this answer by 10, so 2.8, and then divide it by 10 again, which would be 0.28. So let me make sure that answer is really nice and clear there. 0.28. Next one there is all about knowing your column, your place values. So your columns are tens, units, decimal point, which isn't a column, it's always there, and then your tenths, and then matching where the 7.45 goes. And you'll see that there's a gap above here. So what number represents that nothing's there? 0. And then I'm going to take those away. And just be careful, nothing take away 5 you can't do. You'll get -5. You don't want to have negatives doing this. So we're going to put 7 there instead. So we're going to borrow 1 from it. And that one's going to come over to the 0. So it's 10. 10 take away 5 is 5. 7 take away 4 is 3. 3 take away 7 will give me -4, which again I don't want. So it's going to be 13 take away 7, which is 6. So 6.35. Next question says, what is 3 cubed take away 2 to the power of 4? So I need to know what 3 times 3 times 3 is. That's what 3 cubed means. 3 times 3 is 9. 9 times 3 is 27. So we know what that bit is. 2 to the power of 4 means 2 times 2 times 2 times 2. So the power tells you how many 2's are there with time signs in between. 2 times 2 is 4. 2 times 2 is 4. And then with times those together, 4 times 4 is 16. So we're really doing 27 take away 16, which is 11. And then for the bottom question, part D, it says 9 over 10 take away 3 over 5. Well, to do that, you need to have the denominators the same. Notice that 5 goes into 10, and to make it go into 10, we times it by 2. But whatever I do to the bottom of that fraction, to keep it equivalent, I need to do to the top. So I'm going to just change the second fraction to 6 over 10. So effectively, I've times both of those by 2 to keep it equivalent. Then they have the same denominators, which means I can write it over 10, and then 9 take away 6 is 3. So 3/10. Over the page, it says circle either true or false for each of the following statements. 20% of 70 is the same as 70% of 20. Well, we can go and test that quite easily. If I'm to find 20% of 70, let's start by finding 10%. 10% would be 7, so 20% would be twice as much, would be 14. And then if we go and find out what 10% of 20 is, so 10% of 20, that's equal to 2. So 70% would be twice as much, not twice as much, it would be 7 times as much. So it would be 14. They're both 14, so that answer there is true. We then ask, half of an eighth is the same as an eighth of a half. Now to go and work that out, we want to just do a half times by an eighth. So that is 1/16. And then here, 1/8 times by 1/2 would also be 1/16. So that again is true. We're then asked, it says a number is halved, the answer is halved, and this answer is halved again. This gives the same answer as dividing the original number by 6. Now they're trying to get you to fall for a misconception here that you're seeing half being 2, 2, and 2 again being 6. But if you think of it like a pizza, if we have the whole pizza, we cut that in half, and we cut that in half again. It then says, and the answer is halved again. So each of these pieces are halved. I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces there. So that's false. It isn't 6, okay? Now what they're looking for you to do there is doing a half cubed, which would be a half times a half times a half. And then 2 times 2 times 2 would be 8. Okay, so it would be 1/8. Dividing a number by 15 is the same by dividing by 10 and then by 5. So we can actually do that with 15. We know that 15 divided by 15 is 1. Okay, if I do 15 divided by 10, I get 1.5. And then if I do 1.5 divided by 5, I'm not going to get 1. I can quite clearly see. I know that 5 divided by 5 is going to be 1, so I'm going to just put a cross there. I know that's false. multiplying a number by 2.5 is the same as first multiplying by 10 and then dividing the answer by 4. Now that is true, but let me just show you an example sort of a bit further down here. If I do something like, say, 5 times by 6 and then divide that by 2, 5 times by 6 would be 30, and then 30 divided by 2 would be 15. If we look at this bit here, 6 divided by 2 is 3. If I just did 5 times 3, that also gives me 15. And that is because 6 divided by 2 is 3, so it's the same as timesing by 3. So you look here, we've got 10 divided by 4. 10 divided by 4 is 2.5, 2.5, so that's why it's the same. Okay, so that's true as well. Okay, then number 3. It says, a shop has 31 plant pots. Some are blue, some are yellow, and the rest are red. So I'm going to write that out in order here. Blue, yellow, red. There are 5 more blue pots than yellow pots. There are 4 times as many blue pots as there are red pots. Calculate the number of pots there are in each colour. Now I'm going to do this with numbers as a sort of trial and improvement style answer, but I am going to show it algebraically after as well, because it's quite useful to know how to do that. So it says there are 5 more blue pots than yellow pots. There's 31, so if I write here total 31, I know I've got to make 31, so I can't have like an obscene amount of yellow pots. So let's just start off saying that I've got, I don't know, 10 yellow pots. It says there are 5 more blue pots than yellow pots. Okay, that would mean that I have 15 blue pots. And then it says there are 4 times as many blue pots as there are red. So whatever the red answer is, I times it by 4 and I get the blue pot. So that means that going this way, I must have divided by 4. And I can see I can't do 15 divided by 4. It would give me not a whole number, so that doesn't work. Okay, so it can't be 10. Now let's see how close I was here. 15 add 10 is 25, and then we're looking for a quarter of the red pots. So we're probably not a million miles away. I'm just going to add 1 more to the yellows. Now I have 5 more blue pots than yellow pots, so that would mean that I have 16 blue pots, and then we have 4 times as many blue pots as red pots, so it would be a quarter of that, which would be 4. 16 add 4 is 20, add the 11 is 31. So that's my combination. So 16 blue, 11 yellow, and 4 red. Now if I was to do with algebra, it says I have 5 more pots than yellow pots. Okay, so I don't know how many yellow pots I've got, so we'd say x. We'd say that we have x plus 5 in terms of the blue pots, and then we'd have the blue pots divided by 4 for the red pots, and we know all of that has to equal 31. We don't like that denominator there, so we times everything by 4. So timesing this by 4 will give me 20x plus, hang on. You give me 4x plus 20 plus 4x. I'm timesing that by 4 to get rid of this 4 here. And then times that by 4 would leave just x plus 5. And then 31 times by 4 would give me, double it would be 62, so double that would be 124. I've then got x plus x plus x. I've got 4x's, and x. That gives me 9x. Plus 20 plus 5 will be plus 25, which will give me 124. And then from here, I'm just going to work just over by here. So I'm going to say 9x plus 25 equals 124. Taking the 25 off each side gives me 99. And then dividing each side by 9 tells me x is 11. And x is what I said yellow was, so 11 was there, and I can work out the others. It is definitely harder, without a shadow of a doubt. So probably the first way that I did it, actually chucking the numbers in, was a better way around it if we're finding that challenging. But towards the end of the paper, that method's going to be very useful again. Okay then, so we're then asked to go and write down the next 2 numbers of the sequence. So if I look from 33 to 26, I've taken away 7. 26 to 19, I've taken away 7. 19 to 12, I've taken away 7. So I'm assuming that I just carry on taking away 7. That's what's happened in all the terms before. 12 take away 7 will be 5. 5 take away 7 will be minus 2. Part B says, what is 10g take away 5g take away 3g plus 3f? You have to isolate the letters and work them together. So I'm going to look at just the g's to begin with. So I've got 10g take away 3g, which will give me 7g. And then I've got minus 5. and a plus 3f. So that still leave me on the negatives minus 2f there. Okay. Then it says use the following formula: 2t equals m plus 3k. Find the value of k when t equals 11 and m equals 4. So what I need to do is sub in. Let me use the highlighters for the first time. T equals 11, so I know that bit there. And m equals 4, so I know that bit there. What I'm going to do is substitute those numbers in. 2t means 2 times t, so I'm going to say 2 brackets 11 is equal to m. So just because there's no letter, I don't need to put it in brackets, plus 3k. Okay, then 2 times 11 is 22, is equal to 4 plus 3k. I start to want to get the k by itself, so I'm going to take 4 from each side, which give me 18 is equal to 3k. And then finally, to get k by itself, I'm going to divide both sides by 3 to get 6 is equal to k. Okay, then over the page it says these red cards have the following numbers written on them. 3, 6, 9. These 4 green cards have the following numbers written on them. 1, 2, 3, 4. In a game, these cards are turned face down. A player chooses 1 red card and 1 green card at random. The player's score is the sum of the 2 numbers. So basically, we just add the 2 numbers. So for instance, here we've got a 3 and a 1, add them together to get 4. 6 and a 1 is going to make 7, and a 9 and a 1 makes 10. 6 and a 3 is going to make 9. 9 and a 3 is going to make 12. And then 9 and a 4 is going to make 13. And 6 and a 4 is going to make 10. So there we go, first mark from completing the table. It then says a player wins a score if the prize is more than 9. So not including 9, it has to be more than 9. So where is it more than 9? 10, 10, 11, 12, 13. What is the probability that you win a prize? Well, we've highlighted 5 of them. So there's 5 winning chances out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer will be 5 out of 12. We're then told 60 people play the game once. How many people would you expect to win a prize? Well, we know the probability is 5 out of 12. That tells me that every 12 games I play, I'd expect 5 winners. I'm now going to play 60 games. So what have I done to 12 to make it 60? I've times by 5. So we've got to do the same to the top. So that'd be 25 out of 60. So we'd expect 25 winners. Over the page, it says, in this question, you will be assessed on the quality of your organisation, communication, accuracy in your writing. Now, that means when we're talking about shapes, we're talking about saying centimetres. If we're talking about areas, centimetres squared, volumes, centimetres cubed, and so on, and just having a nice logical way to our working. We don't need to write an essay. We just need to make sure we explain things as we go along. Okay? It says a right angle triangle, BCD. So let's go and identify what that is. BCD. Okay, so that's this guy here. Is joined to a rectangle ABDE. So ABDE, as we can see, is this guy here. Okay, we're told that the area of the rectangle is 45 centimetres squared. So we can go and put inside there 45 centimetres squared. Calculate the area of the right angle triangle. Now, to work out the area of the right angle triangle, we need to know what the base times by the height is and then divide it by 2. I can see that at the moment I don't know what the height is. I don't know what this length here is of the rectangle. And if I do know it, I'll know the height of the triangle there. The base I can work out by doing 15 take away 9, which will tell me what's left here, okay? But to begin with, let's work out what this missing side is. So I'm going to say area of ABDE is equal to length times width. Okay, that's a mathematical formula you're expected to know. We know the area is 45 centimetres squared. We don't need to write it until our very final answer, though, in terms of our units. Our length is 9. Our width, we don't know. And then to get rid of a times by 9, I'm going to divide both sides by 9. So 45 divided by 9 is 5, or 5 centimetres would be equal to the width. So can we then go and say this is AE, and is this length here as well, BD, which is the height of triangle. Okay, we've worked out the height of the triangle. Now we need to go and work out the base. I know it's at the top, but if we flipped it around, it would be the base. We tend to use that formula, base times height divided by 2, when we're talking about a triangle. So to work that out, so base of triangle is equal to 15 take away 9, which is equal to 6 centimetres. So area triangle is equal to base times height divided by 2. So the base would be 6, the height would be 5, as I just worked out, and divided by 2. 6 times 5 is 30. 30 divided by 2 is 15 centimetres squared. Okay, 15 centimetres squared. Okay, then over the page, have a quick look at the questions. I'll start to go through them in a moment. Okay, then. So, to solve equations, we need to get the letters by themselves. The first one's very easy. To get rid of a divided by 5, we just need to times both sides by 5. That would leave just W there. Effectively, those two cancel out, and then 10 times 5 is 50. This one's much harder, okay? The unknown is at the bottom. We don't like it being at the bottom, so I need to get rid of it being at the bottom. So I'm going to times both sides by x, because I'm divided by x. To do the opposite of divided by x, I'm going to times both sides by x. Now that will cancel out the x being on the bottom like we wanted, leaving just the 42 there. And now we're going to get 7 times x, or 7x, okay? Now to get the x by itself, we want to get rid of the 7. The 7 is times in by the x, so we're going to divide both sides by 7. 42 divided by 7 is 6. So 6 is equal to x, or x equals 6. Either of those answers is fine the way they're written. Okay. The one underneath is harder again. We have y's on both sides of the equation. So what we do is we get rid of the smallest y. So 13y and 9y. The smallest y is 9y, so we take 9y off each side. 13y, take away 9y, is 4y. I still have a minus 5 there, so that needs to come down. The 9y's have cancelled, leaving with me with just positive 27, or just 27. Now I need to get the y by itself, get rid of anything not physically attached to it. So the minus 5 isn't attached, that's the easiest to get rid of. We add 5 to both sides to get 4y is equal to 32. And then finally, to get y by itself, we're going to divide both sides by 4. That's going to cancel the 4's, leave me just with y. And then 32 divided by 4 is 8. Okay then, best advice I could give you here, if you're unsure, make sure that you're actually just writing down some numbers that work here. It says, 2 types of number are added or multiplied together. Complete the table to show whether the answer will be odd or even. One answer has been filled in for you. So the first one says, what is an even number, add an odd number? Well, choose an even number, any even number. So 10, add an odd number, choose any odd number, 7. 10 add 7 is 17. That is odd, so the answer must be odd. Okay, the next one says, what is an odd number, add an odd number? So let's try 7 add 3. 7 add 3 is 10, so that's even. So an odd add an odd must give me an even answer. What is an even number times by an even number? So 4 times by 6. 4 times by 6 is 24. Even, that is also even. So that would be even there. Even number times by an odd number. So again, 4 times by 7. 4 times by 7 is 28. That's even as well. So an even times by an odd is even. And then an odd number, so 3 times by another odd number, 7. 3 times 7 is 21. That's an odd number, so that must be odd as well. Okay, then over the page, question 9, have a quick read through of it. I'll go through it in about 10 seconds. Okay, then question 9, it says, write down the 5 numbers that satisfy all of the following conditions. They are all between 1 and 9 inclusive. Now, inclusive means it can include 1 and include 9 if it needed to. They have a median value of 6. The range, they have a range of 7, and their mean is 5. Now, if we start working through these numbers here, or these bullet points here, we can start to put numbers in. They can be all between 1 and 9, including 1 and 9. Okay, so they can't be double digits. It has a median value of 6. Well, that one has to be 6. Now, this one must be the lowest, and this one must be the highest. Okay, median means the middle number must be 6. They have a range of 7. So we're starting to think of the pairs of numbers that we could have. So 9 take away 2, for example, would give me 7. That would give me a range of 7. 8 take away 1 would also work, okay? Now, you can pick either one. It doesn't matter. I'm just going to pick the second one, okay? So I'm going to have 8 go there and 1 go there, okay? So now I've dealt with that. We're then told that the mean has got to be 5, okay? Now that means that when I add up all my numbers, add all of them up, so add 1, add something, add 6, add something, add 8, and then divide that by 5, it must come to 5. Okay, that's how we work out the mean. So all of these numbers, to get rid of that divided by 5, if I times both sides by 5, all of those numbers, so the 1, add something, add 6, add something, add 8, must come to 25. Well, if we work out what we've got so far, we've got 6 add 8, which is 14, add 1 is 15. These two numbers here, so this number here and this number here, which is this number here and here, they must add up to 10, because 10 would then take us up to 25. So we're looking for any pair of numbers that add up to 10 that still satisfy my condition where this is the lowest number and this is the highest number. So we've got to have one less than 6 and one higher than 6. So it can't be 5 and 5 because that wouldn't fit. Can't be, or it could be 4 and 6. There's no reason why 4 couldn't go there and 6 could go there. It could be 3 and 7. It could be 2 and 8. It could be any of those numbers there. I'm going to go with 3 and 7, so I'm not repeating any numbers, but it really doesn't matter. There's a load of combinations that will work for that, okay? Question 10. It says, how many sides does this polygon have? And I missed the first bit. It said a regular polygon has exterior angles of 45 degrees. Now, there's a few key words there, okay? Regular means they're all the same size. Exterior angles, you need to know that these all add up to 360. If I do 360 degrees divided by the number of sides, I'll just say divided by n for now, that will tell me what one angle is, and they told me that that is 45 degrees. So rather like my question before, I need to now work out how to get n by itself. So I'm going to times both sides by n. I'm going to drop the degree symbol, so I don't strictly need it in an equation. I can put it back in at the end if it needs to be there. That's going to give me 45 times n, and then to get the n by itself, I need to divide by 45. And I need to work out how many 45s go into 360. Now, I don't know how many 45s go to 360, so what I'll do is I'll start writing out 45 times table, which is not as bad as it sounds. 45 doubled is 90, and then I would, that's times by 2. If I double that, I get 180, so that's times by 4, so I've doubled it again. And then doubling it again would be times by 8, would give me 360. So it tells me that 45 goes into 360 8 times. So n equals 8. The number of sides is equal to 8. Part B, it says sketch. Each side of this regular polygon is 7 centimetres. A sketch of two sides A, B and BC of the polygon is shown below. Using a ruler and a pair of compasses, construct an accurate drawing that shows these two sides of the polygon. You must show your construction arcs. Now, your pair of compasses is just this, okay? And there's a couple of angles that you are expected to know. You're expected to know how to construct 90 degrees, and you're expected to know how to construct 60 degrees. All other angles they could ask you to draw will be a variant of those two there. Take, for example, R45 they want us to do. I'm going to write it under the 90 because you should notice, as we just saw above, that 90 degrees divided by 2 this time, sorry, not times by 2 like the last one, is 45. So what I need to do is to draw accurately to begin with 7 centimetres. So make sure 0, the end dot is on A, and I'm looking for 7, and it has to be exactly 7, okay? Not 7.1, not 6.9, it has to be exactly 7. That is 7 centimetres. I now need to construct 90 degrees here, okay? So I'm going to put a little blob on the end of that. That's going to make my life slightly easier. And I'm also going to draw very faintly an extension of my line, okay? Now, I'm going to write B there so it's nice and clear that I haven't mismeasured my lines anywhere at all. And to construct 90 degrees, what I need to do is make sure that B is bang in the centre of that line. So what I do is I open my compass to a little bit, probably about 3 centimetres. I draw an arc there, I move him around and draw an arc there, okay? Now, I know that B is exactly in the middle of that line. What I'm going to do is now bisect this line to make sure that I'm constructing an angle of 90 degrees. So to do that, I open my compass to a little bit more than the width just was, and I put it at one end where the arc crosses the line, the faint line that I drew, and I draw an arc there. and I move it over at exactly the same width over to where the other arc hit the line, the bold line, and I draw an arc there. Oh, probably getting what you're getting. I like to just rotate the paper normally. Makes my life a bit easier. There we go, like that. And then I line up B and the dots there, and I can draw there a faint line. I don't want it to be really, really, really bold, but if I draw that line there, I've made 90 degrees. You can see quite clearly that's 90 degrees there, which means it's 90 here, 90 here, and 90 here. Okay, now I've got to make this angle 45 degrees. So now I need to bisect this angle here, which is effectively, I wouldn't recommend doing this on your sheet, but effectively what I'm going to do is bisect this angle here of 90 degrees to effectively go and work out that 45 there. Okay, now to bisect that angle, what I need to do, keeping my compass at the same width as before, I draw an arc that crosses the 90 line that I drew up and that faint line again that I drew. I go and draw two blobs where the arc intersects the line, so there and there. Okay, now from there I keep the compass at the same width and I draw an arc in here. Oh, again, I'm actually going to just move the paper because it's making my life a lot harder not doing my usual method just because the camera's over it. And then moving that over here like that. Okay, now where those two arcs meet there, I draw a blob. Where my angle started here, I draw a straight line through them. Now it was supposed to be a side of, because it was a regular polygon, that means that 7 there is also that line there. So that line needs to be 7 centimeters also. So I'm just going to measure 7 centimeters. Again, 0 on my point there. And then 7 would have stopped here. I'll just mark that really nice and crystal clear and put C next to that. Okay? That was a tricky question for constructions. That wasn't easy. They're not easy at the best of times, so that's a particularly hard one. Okay, a slightly easier one to get us going now. A bit of substitution, then plotting. I'll give you a chance just to get a bit of a heads up. Okay then, we're asked to find some missing values in the table. We're told what the value of x is. We need to find out what the value of y is related to that formula. Now the way that I do this is we just change the x to open brackets, and then what the value of x is, the number above goes in here. So -1 goes in there, -1 goes in there. Okay, you now work through this using BIDMAS. -1 squared is +1. +1 times 2 is 2. -5 times by -1 is +5. And then we need to take away 1. 2 plus 5 is 7. 7 take away 1 is 6. So 6 is going in there. And in the next one, here, I'm going to do again 2 open brackets squared, -5 open brackets, -1. And the value going there this time is 2 and 2. 2 squared is 4. 4 times by 2 is 8, or 2 cubed, as we've seen loads of times already today. -5 times by 2 is -10, and then take away 1. 8 take away 10 is -2. -2 take away a further 1 would be -3. So that's the number that's going in there. We're now going to plot those values onto my graph paper. So we've got -2 and 17. Let's just work out this scale very quickly, something that's commonly done really badly. We can see that we go from 0 to 5, which is a jump of 5 in 10 little squares. So we do 5 divided by 10, which tells each little square is worth 0.5. Okay, so 0.5, 1, 1.5, 2, I can't even draw it myself now, 2.5, 3, 3.5, 4, 4.55. So just double check you understand how that's happening or what's working there. I'm going to plot these bits really quickly now. So -2 and 17, -2, here's 15, here's 20, 17.5 would be in the middle, so 1 down would be 17, take away the 0.5 there. We then have -1 and 6, so there's -1 and 5, and then 2 little squares up would be 6. 0 and -1, so just 2 little squares down. 1 and -4, so 2 little squares up from -5. -2 and -3, so -2.5, -3. And then 3 and 2, 2.5, so 1 down from 2.5, and then 4 and 11. So there's 10, 2 little squares up from there. You should get some, whenever you're looking at an x squared graph, you're going to get a graph that looks something like that. It's got to be drawn freehand. I always go to the bottom point. And don't just stop at the last coordinate, just carry on like that, okay? And similarly here, curved at the bottom, like that. Okay? So it should look something like that. It then says, draw the line y equals 5. Now this does what it says on the tin, but people do struggle with this graph. Y equals 5. Find y, find where it's 5. There. It's a line that goes through there on the y-axis, okay? So I'm going to draw a nice bold line using a pen. That is y equals 5. We're now looking where that graph hits that line. So I can see it's there, and I come down and read off the x value. So that's 3.4 is 1. And this one here is minus 0.9. Okay, 1 short of minus 1. So then I go and write those values in here. So minus 0.9, so you can see. And 3.4 will go there. It then says circle the equation below whose solutions are the values you just solved. Now this bit's hard, okay? If you struggle with this bit, it is a hard one. Basically, we've just solved this graph and this graph. We've said 2x squared minus 5x minus 1 is equal to that graph there. You just ignore the y's and put them equal to each other. Now, notice all of these say equal to 0. So they've got rid of this 5 here, so they take away 5 from each side. Now, the 5 only deals with the numbers. The 2x squared doesn't get affected, neither does the 5x. And minus 1 minus 5 is minus 6 equals 0. So we're looking for that option there, which is the second one. Okay. Over the page, number 4, it says a fair 6-sided dice and a fair coin are thrown together once. Circle the correct answer for each of the following statements. The number of possible outcomes. Now, you always do the number of outcomes. So on a 6-sided dice, it's 6, and on a coin, it's 2, and you multiply them together to work out the number of outcomes. So 6 times 2 would be 12. The probability of getting a 4 on the dice and a tail on the coin. Now, that can only happen in one place. 1 4 and 1 tail. So we're looking 1 out of 12, which would be that one there. And then it says the probability of getting a multiple of 3 and a head on the coin. So multiples of 3 is the 3 times table. So 1 times 3, 2 times 3, 3 times 3, 4 times 3, etc. Okay. Now, in terms of what numbers fit on a dice, 3 does, 6 does, but these don't. So we've got 2 different chances out of a total of 12. Okay, out of the total outcomes of 12. And as we know, we can cancel both of those down because they're both even numbers. So that'd be 1 out of 6, which is that one there. Okay, then over the page, it says question 13. Make m the subject of the formula. Now, making something the subject of the formula is very similar to solving an equation. If I had, for instance, 2x plus 1 equals 14, I would say start by taking 1 off each side, then get 2x equals 13. We'd then divide both sides by 2 and get x equals, 13 over 2. Bad numbers on my part, but that's how we do it. Now, this is exactly the same idea. Make m the subject means get m by itself. So we start off by getting rid of the plus 7. So we take 7 from each side. But easier than last time, we don't actually have to work out any of the maths. We can't because it's algebra. We just say it's y take away 7 is equal to 6m. Now to get the m by itself, I divide both sides by 6. And we're finished. It's y take away 7 over 6 equals m. Done. Factorise means put back into brackets. So we're looking for a number or a letter that goes in both. I can see that 6 goes in both, and I can see x goes in both. So 6x comes outside. 6x times what makes 6x squared? Well, x times x would make the 6x squared. And then 6x times what makes 12x? Be take away 2. Note your bracket, there shouldn't be anything common in both. There shouldn't be like an x in both or a number that I can divide into again. Question 14, a bit sneaky. It says, find in standard form the value of each of the following. The one on the bottom isn't in standard form, so it wants you to put it into standard form. Now, 5,000 we should know would be 5 times 10 to the power of 3. You then look at doing the numbers dealing with the numbers and the tens dealing with the tens, okay? So how many 5s go into 7.5? It would be 1.5. And then powers of 10 means that I subtract the powers when I'm dividing, so it would be 1.5 times 10 to the power of 3. And then this one here is not quite as simple. That only works timesing and dividing, that method that I just used. Here, we have to take it out in standard form, solve any adding and subtracting questions. So 2.3 times 10 to the power of 3 would move that decimal point 1, 2, 3 times because it is the power of 3. Okay? Now, that would then effectively come here and I'd have noughts in between. So it's going to come 2300, 2300. And then 6.4 times 10 to the power of 4 would move it 1, 2, 3, 4 times to there. So 1, 2, 3 there. So it's a slightly bigger number. So I need to make sure I've written these in column addition. So I've got 3 zeros and a 4 and a 6 goes there. Usually I put the bigger number up on the top. I could rewrite it if I want, but because I'm adding, it doesn't make a difference. 0 add 0, add 0, 3 add 0, 2 add 4, and then 6 add nothing. So then to put that back, that decimal would jump back 1, 2, 3, 4 places. So it would be 6.63 times 10 to the power of 4. Okay, then over the page, have a quick read of the question. I'll start to go through it in a moment. Okay then, it says each side of a square has length 2x plus 3y. The perimeter of the square is 62 centimetres. Each side of a regular octagon, so that word coming up again, so regular means they're all the same. You could say this is a regular quadrilateral, that is the definition of what a square is. And it has a perimeter of 72 centimetres. Use an algebraic method to find the value of x and the value of y. Okay, so we're going to highlight a few things here. So starting with the square, we know that the length is 2x plus 3y. So that's that side there, and that side there, and that side there, and that side there. And the perimeter, that distance around it, must come to 62 centimetres. So I'm going to say that 4 lots of 2x plus 3y comes to 62 centimetres. That's what that's telling me, okay? Now, similarly here, regular octagon tells you there's 8 sides and they all have this. So this side here is the same here, 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 here. All of these, okay? Because it is an octagon, I would have said that 8 times, and I can put that equal to 72. So I'm going to say 8 brackets x plus 2y, close brackets, equals 72, okay? Now the next thing, you'll notice that I've left some space. I'm going to expand those brackets, each of them, and work them out, okay? 4 times by 2x would be 8x. 4 times by 3y would be 12y. That's equal to 62. That is my first simultaneous equation because I have x's and y's in it. Expanding this one out, I get 8x and then plus 16y is equal to 72. Okay, so that's my second equation. Now, because I have the x's the same, I want to do equation 1 take away 2 or vice versa, whichever one has the biggest y, I'll do first. You can see 16 is bigger than 12. If we work with equation 2, take away equation 1, it will make our life easier. 8x take away 8x is gone. 16y take away 12y is 4y. 72 take away 62 would be equal to 10. Now, as we know, this has already come up in this video today, that 10 divided by 4 is 2.5. So y would be equal to 2.5. So I can go and write that in down at the bottom. Now I know the value of y, I'm going to substitute it back into one of the original equations, okay? Either 1 or 2. I tend to use the one with smaller numbers, so I'm going to choose 1. So I'm going to say sub y equals 2.5 in 1. So I get 8x, I don't know what 8x is, so I don't know what x is, so that stays the same, plus 12y, so plus 12 times by 2.5. That equals 62. Now, 12 times 2.5 I don't know. But what I do know is what 12 times 2 is, that's 24. And I do know what 12 times 3 is, that's 36. So 12 times 2.5 must be in the middle of those two numbers. So what's in the middle of 24 and 36? 30. So I can then say 8x plus 30 is equal to 62. I'm now going to take 30 from each side to get 8x is equal to 32. And then dividing both sides by 8, I'm going to find that x is equal to 4. So x is equal to 4. Over the page, it says, Alwyn often drives from Bangor to Cardiff. He always chooses one of 2 routes for these journeys. he either travels through Radnor or through Hereford. The probability that he travels through Radnor is 0.7. Sometimes he decides to stop for a break on his journey. His decision is independent of the route he takes. So that just means it doesn't matter which route he takes. It doesn't affect the likelihood of him stopping for a break. The probability that he travels through Radnor and stops for a break is 0.42. Now, that's really important. All of those things there. They put that in bold, so it must be important. So let's follow that. Radnor and stops for a break tells me what the answer is. You should know for probability trees that A, each branches add to 1. So 0.7 add 0.3 makes 1. And then you multiply these two branches to get this answer here for the probability. And we know what this answer is. We don't know that's 0.42. We know that the answer is 0.42. So the question we've got is 0.7 times what makes 0.42. You should know that's 0.6. So that would make this 0.4, and because they're independent means that I can use exactly the same numbers on the other branches. It then says calculate the probability that he travels through Hereford and does not stop for a break. So through Hereford and no break would be those numbers there, and I multiply them together. So 0.3 times 0.4 will give me 0.12. Okay, we are on to the last question. We've got through this pretty quickly today. Have a quick read of it. I will go through. It is very similar to question number 3 that I did with algebra. Okay, this is the question I was on about. It will be useful later on. Okay then. William has n marbles. Lois has 4 times as many marbles as William, but she has now lost 23 of them. Lois still has more marbles than William. Write down an inequality in terms of n to show the information above. Use your inequality to find the least number of marbles that William may have. Okay, now the way I'm going to do it to begin with is I'm going to say William and Lois. Okay, now William has n marbles, so I'm going to put n underneath William. We're told that Lois has 4 times as many, so 4n, but now she has lost, so we're losing 23 of those marbles. So algebraically, if William has n, Lois has 4n minus 23. We're told then that Lois has still got more marbles than William. So that means the amount of marbles she has, 4n minus 23, is more than William's marbles is more than n. Now this is effectively now just an equation. We're going to start off by getting rid of the smallest n I'm going to start off with. So rather than putting an equal sign there, I just do an inequality sign. And I'm going to take n from each side. Okay, so I want to get n by itself eventually. 4n take away n is 3n. I still have the minus 23, and then n take away n would leave me with nothing that side. Now, to start getting the n by itself, I need to get rid of anything not physically attached to it, so the 23. And nothing add 23 would just be 23. So 3n has got to be more than 23. And now finally, to get the n by itself, I would divide both sides by 3. Now this is requiring you to know a little bit of logic here in terms of writing a fraction as a mixed number. How many 3's go into 23? 7 remainder 2, so 7 and 2/3. So William's marbles has got to be more than 7 and a bit. Okay, well, so he's got to have at least 8. And we're asked to go and work out what is the least number of marbles that William may have. So the least number of marbles he has, so William has at least 8 marbles for that formula or that equation to work. Okay, thank you very much for watching. I hope it's been useful. If it has been, please hit the subscribe button and you will get access to any videos in the future as and when I release them. Thanks again for watching.